Hello guys, today I'm going to show you how to use the GPS module and how to test the GPS module. So my part number is the ZEDF9P02B. I'm using this part number for GPS module. Okay. The GPS module picture is this, and the feature of this GPS module. So GPS module having the multiple peripherals like SPI, I2Cs, and the UART and USB as well. So this GPS having the good capability. So this GPS can be communicated with the multiple satellites. You can see here, and there is a 2L receiving band we can use, and the what is supplying level is 5 voltage and 3.3 voltage is required. So and the overall current consumption of this module is the 35 milliampere. So the GPS accuracy, we can discuss about the accuracy of this module. So horizontally accuracy, the position accuracy is this GPS module without RTK is the 2.5 meters. If suppose we are enabling the RTK function, so the GPS module accuracy is more increasing more and more. So that accuracy is 0.010 meter. Okay, and this is the overall block diagram of the GPS module. Here you can see the RF antenna, here you can see the power supply, this is the crystals, RTC, and the flash memory internally. So we can use the multiple peripherals capabilities. So here is the external interrupt selection, deselection, RTK status, time pulse. So the time pulse is required to suppose we have to receive the data in particular duration. So we are configure that duration by using the time pulse. So we can get that pulse at high as an input. We can read in microcontrollers, and then we can program it. That's why the time pulse is required, and the RTK states is also there is. So and the deselection is required. There is the two peripherals is combinedly used UART and the SPI. So suppose you have to configure the SPI pins, so that time you select to deselect jumper is used there. So deselect pin you have to attach with directly connected to the ground. That means that time suppose you are connecting this deselect pins directly to the ground, then means your SPI peripheral is enabled. Otherwise by default there is the UART pins is enabled. So you can see here the pin out. This is the basic schematic diagram of this module. So you can see here the deselect pins. There is the one jumper is using. If suppose you are inserting that jumper, otherwise sorting that, so by using the solders, that there is a SPI is enabled. Otherwise by default there is the UART2 is enabled peripheral. So this is the USB testing. This is PC USB 2.0, and this is directly connected by using the C type USB to directly module without any external power supply is required by using the USB cases. So this is a SMA, and this is my antenna. You can use also this part number. I use this part number for the testing. This module also having the compatibility with the UART. You can test by using any microcontroller or SBCs. So as well as the I2C compatibility by using a SCL SDA pins is available on this board. So external power supply is also required by using the I2C, SPI, and the UART cases. So now I use this is SPI protocol. So SPI protocol having the chip selected pin SCK, MOSO, and MISO pins. So I can directly communicate by using the SPI with any controllers. Okay, but you have to enable the SPI, so you require to sort this jumper here. Okay, so in this module for the configuration is required the U BLOX software. The U BLOX software is basically used for the configure this module. This is GPS module, which timing pulse you require, which peripherals you are using, the whatever, and what form you require, the output form, frame formats, as well as the protocol timing, and as well as the logging timing, everything you can configure by using this softwares. Okay, so I connected the satellite. I selected to communicate with the satellite GNGGA, and this is by using the USB peripheral. So this is my log. You can see here GNGGA. Also, I tested by this module by using the STM32 microcontrollers. So this is my code, basic code, and you can see here that there is my log is data is received in my buffer, data received buffer. You can see here.